Hello everyone, welcome back to my channel. In this video we will talk about data preparation and modeling in Python. Let's start with the first step of data preparation and modeling. The first one is partitioning the data. Partitioning the data is a crucial step to ensure a fair evaluation of the model. The dataset is typically divided into three subsets: training set, validation set, and test set. Now, what is training set? Training set is used to train the model. Validation set helps fine tune hyperparameters and prevent overfitting. Overfitting occurs when a machine learning model learns not only the underlying patterns in the training data but also learns noise or random fluctuations. Test set used for unbiased evaluation of the final model. Next step is balancing the training dataset. Balancing ensures that the training data does not suffer from class imbalance, which can bias the model. Technique includes oversampling, example SMOTE in Python. Oversampling involves increasing the number of samples in the minority class to balance the dataset. Undersampling, randomly reducing the majority classes. Undersampling involves reducing the number of samples in majority class to balance the dataset. Synthetic sampling, creating synthetic samples for minority classes. Synthetic sampling is a specialized form of sampling where synthetic data is generated from minority class. Libraries Libraries like Imbalance, Learn, Python, and ROSE are simplify the balancing task. Building cart decision tree. Cart decision tree is a popular decision tree algorithm that is used for both classification and regression tasks. Classification and regression trees CART split the data based on the feature thresholds to maximize homogeneity within the nodes. In Python, we use decision tree classifier or decision tree regressor from sklearn package to implement the cart decision tree. Cart is useful for its interpretability and handling the non-linear relationships. Number fourth step is building C5.0 decision tree. C5.0 is an improvement over the C4.5 algorithm, offering better performance and flexibility. It uses information gain to determine splits. In Python, while no direct implementation exists, one can mimic it using libraries like sklearn by carefully setting tree building parameters. Building random forest. It is the fifth step of this data preparation and modeling. The random forests are ensembles of decision tree created using random feature, subsets, and bagging techniques. They improve accuracy and reduce overfitting. In Python, the random forest classifier or random forest regressor from sklearn are used to implement the random forest. Random forests are robust, handle missing data well, and provide features and importance insight. Now let's see the data preparation phase to model the data, the task involved in it. Let's see it in Google Colab. First one is partitioning the data. Partitioning Partitioning splits the dataset into training and testing subsets. For model evaluation, we will use sklearn package to import train test split library. Let's In this we have given the example dataset: age, salary, and purchased. This is the dataset, and we have converted into data frame. Features and target. These are features age and salary, and the target is purchased. Split the data, then we split the data into 80% train and 20% test. X train, X test, Y train and Y test. Now we can split the data according to the size 0.2, test size 0.2, which is 20%, and random state 42. Check the partition sizes. We can also check the partition sizes and the using this dot shape function. Now let's run this command. It's running. So the training data shape comes to be 6, 2 means 6 rows and 2 columns, and test data shape comes to be 2, 2 which is 2 rows and 2 columns. The next step is to balance the training dataset. Imbalanced datasets can bias the model. We can balance the dataset using oversampling or undersampling. Balanced datasets can bias the model. We can balance through this oversampling and undersampling. So here we are importing this SMOTE, means for oversampling. So here is the feature and the target. We have converted into data frame. X is equal to df in brackets feature and y is equal to df in bracket target. Before balancing original target distribution, we have set a counter y. After applying the SMOTE, balance the dataset. Set k neighbors to values less than or equal to the number of minority samples. SMOTE, in this we have done x balanced and y balanced. In SMOTE fit resample x comma y. This is the function that we have used to do the oversampling. Now let's just run this command. So this original target distribution was counter 0, 5, colon 3, and the balanced target distribution is counter 0, colon 5 and 1, colon 5. So it's just a balance in 5 and 5. The next step is to build the cart decision tree. Cart classification and regression trees uses Gini impurity or entropy for splits. In cart we use Gini impurity or entropy to split the data. Here we have imported the matplotlib library and sklearn. From sklearn we have imported the decision tree classifier and plot tree. Here we are training the cart decision tree. In this we have used the criteria as Gini and random state 42. So let's just run this command. Yes, so the output comes like cart decision tree, and it is made the full decision tree based on the Gini impurity. As you can see here, it has used the criteria of Gini impurity. Now the next step is building C5.0 decision tree. The C5.0 is an extension to the ID3 algorithm with better accuracy and pruning. In Python, you can use the sklearn.tree.class decision tree classifier with entropy as the criterion to approximate C5.0, train a C5.0 decision tree approximated using entropy. So here we have implemented this C5.0 decision tree using this criterion as entropy and random state as 42. Yeah, here we have done the fitting of x train and y train, and now in the next statement we have plotted the tree. Let's just run this command. So it comes like the decision tree, which has used the criterion of entropy. Here the entropy comes to be first entropy is 0.918, which is the highest entropy. Then we have separated the decision tree values and we have made a tree. Now the next step is building. Next we can use is building random forest. Random forest combine multiple decision tree to reduce overfitting and improve accuracy. From sklearn.ensemble, import random forest classifier. We have to import the random forest classifier from sklearn.ensemble package. Train the random forest. We are training the random forest, and we are using the n estimators as 100 and random state as 42. We have done the fitting of x train comma y train, and now we have done the feature importance here. Now let's just run this code. So the feature comes to be 0.50. So that's it for this video. Let's meet in another video.